Welcome back to the Network Plus training series. Today we're covering Objective 3.3, High Availability and Disaster Recovery. Here's the truth about networks. Every single one of them is going to fail eventually. Not if, when. A hard drive dies, a backhoe cuts your fiber, a rack loses power, someone pushes bad config on a Friday afternoon. Your job isn't to prevent every failure. That's impossible. Your job is to plan so that when failure hits, you're ready. Let's start with the numbers because these four metrics are absolutely going to be on the exam. First up, Recovery Point Objective or RPO. RPO is all about data loss. It asks, when the worst happens, how much data can we afford to lose? Measured in time. If your RPO is 4 hours, you're saying it's acceptable to lose the last 4 hours of data. That number drives your backup schedule. If you've got a 4-hour RPO, you need backups running at least every 4 hours. Want a 15-minute RPO, you're looking at near continuous replication. The lower the RPO, the more expensive your backup solution. Then there's Recovery Time Objective, RTO. This one's about downtime. How long can the business survive without this system running? A 2-hour RTO means you've got 2 hours from the moment it breaks to the moment it's back up. RTO drives your recovery procedures. Tighter RTO means hotter standby systems. Quick tip, people mix RPO and RTO constantly on the exam. Easy way to remember, RPO is about data. RTO is about time to restore. Data loss versus downtime. Next, MTTR, mean time to repair. This is the average time it takes your team to fix something once it breaks. Diagnosing, getting parts, actually doing the repair, verifying it works. Lower MTTR is better. It means you've got solid processes and good spare parts inventory. And MTBF, mean time between failures. This is the reliability metric. How long does a device typically run before it fails? Higher MTBF means a more reliable device. Vendors publish MTBF for hardware. You use it to plan maintenance windows and decide how many spare units to keep on the shelf. So, RPO, RTO, MTTR, MTBF. 4 metrics. Memorize them. Now let's talk disaster recovery sites. A DR site is a second location you can fall back to when your primary gets taken out. There are 3 flavors and they're all about trading cost against recovery speed. A cold site is basically empty real estate. You've got the building, power, cooling, and an internet connection. But no servers, no data, no network gear installed. When disaster hits, you're shipping equipment in, configuring from scratch, restoring from backups. Cheapest option by far. But we're talking days to weeks before you're back online. Cold sites work if your business can tolerate being offline for a while. A warm site is the middle ground. You've got the infrastructure and some pre-installed hardware, maybe even recent backups sitting there. You can have things running in hours, maybe a day, but it's not instant. Still needs some setup and data restoration. A hot site is a live, fully running duplicate of your primary site. Same hardware, same software, same data, kept in sync in near real time. When primary goes down, hot site takes over in minutes. Expensive, absolutely. But if you're running a hospital or a bank, this is table stakes. Cold, warm, hot, slow, medium, fast, cheap, mid, expensive. That's the trade-off. Now, high availability. Different beast from DR. DR is about recovering from the disaster. HA is about making sure the disaster doesn't take you down in the first place. You design redundancy into the system so individual component failures don't become outages. 2 classic patterns. Active-active and active-passive. In an active-active setup, multiple devices are handling traffic at the same time. Say you've got 2 firewalls, both are processing packets, both are passing traffic. One dies, the other picks up the full load. You get redundancy and you get load balancing during normal operation. Downside, it's more complex to configure. Asymmetric routing can get weird. State synchronization between the devices is non-trivial. In active-passive, one device does all the work while the other just sits there waiting. Standby. If the active device dies, the passive one takes over. Simpler to set up, but you're paying for a device that's idle 99.9% of the time. It's not pulling its weight until something breaks. Quick exam call out. Know when to choose which. Active-active for performance plus redundancy. Active-passive for simplicity plus cost savings. Redundancy itself happens at a bunch of layers. Device redundancy, duplicate routers, switches, firewalls. If one fails, the other takes over. Link redundancy, multiple paths between devices. One link fails, traffic reroutes. Power redundancy, dual power supplies per device. UPS units, generators. Geographic redundancy, infrastructure in multiple physical locations. Protects against things like a data center fire or a regional outage. You layer these together. Redundant devices connected by redundant links powered by redundant supplies, replicated across geographic regions. Each layer covers a different failure mode. Speaking of redundancy, first hop redundancy protocols or FHRPs. These exist to solve one specific problem. What if a host's default gateway dies? Without FHRP, every host on that subnet loses internet access until you manually repoint them to a different gateway. That's not acceptable. FHRP lets two or more routers share a single virtual IP address. Hosts point at the virtual IP. Behind the scenes, one router is active, the others are standby. The active router fails, the standby takes over, clients never know anything happened. The three you need to know: HSRP, Hot Standby Router Protocol; Cisco proprietary, one active, other standby; VRRP, Virtual Router Redundancy Protocol, open standard. Essentially the same idea as HSRP, but works across vendors. GLBP, Gateway Load Balancing Protocol, also Cisco. This one's fancier. It actually load balances across the group instead of keeping standby routers idle. Exam trick. If you see open standard, think VRRP. If you see load balance across gateways, think GLBP. HSRP is the vanilla Cisco answer. Quick mention of NIC Teaming, taking multiple physical network cards on a single machine and bundling them into one logical interface. You get more bandwidth and fault tolerance. One cable gets unplugged, traffic keeps flowing through the others, common on servers and high-end workstations. Alright, so you've built all this redundancy, planned your DR sites, documented everything. How do you know it actually works? You test it. A tabletop exercise is the easy kind. Get the team in a room or on a call and walk through a scenario. Primary data center just caught fire. What do? Everyone talks through their role, identifies gaps, updates runbooks. No systems touched, no downtime. Cheap, low risk, great for onboarding new team members. A validation test, also called functional or full-scale test, is where you actually execute the plan. Restore from backup. Fail over to the warm site. Spin up the hot site and route real traffic to it. This is disruptive. It's expensive. But it's the only way to know with certainty that your DR plan works. Nothing beats actually testing the thing. You run tabletop exercises quarterly, validation tests annually. That's the rhythm at most mature shops. Backup strategies. 3 types. Know them cold. Full backup. Copies everything. Takes the longest, uses the most storage, but gives you the simplest restore. One backup equals full recovery. Incremental. Only copies what changed since the last backup of any kind. Small, fast backups. Restore is painful though. You need the full backup, plus every incremental since. Differential. Copies what changed since the last full backup. Bigger than incremental, but smaller than full. Restore is simpler. Just the full plus the latest differential. And the 3-2-1 rule, this is your backup Bible. 3 copies of every critical piece of data. 2 different storage media types, say disk and tape or disk and cloud. 1 copy stored offsite. Why? Because if ransomware encrypts your production data and your local backup, you still have the offsite copy. If the building burns down, offsite saves you. 3-2-1. Memorize it. Let's wrap up. You've got 4 metrics: RPO, RTO, MTTR, MTBF, 3 DR site types: cold, warm, hot, trading cost against recovery time, 2 HA configurations: active for performance, active-passive for simplicity, FHRP for gateway redundancy, HSRP, VRRP, GLBP. Test your DR plan with tabletop exercises and validation tests. Back up with the 3-2-1 rule. The goal isn't preventing failure. The goal is making failure boring. Just another Tuesday afternoon your team recovers from without breaking a sweat. That's Objective 3.3. In the next video, we will cover Objective 3.4 on network security concepts. See you there.